functionality. All right. Now then there is also a split here vertically, and vertically meaning not only can you be in different execution level, but within each execution level, there is a concept of the non-secure and secure. And once I paint use cases, things will make perfect sense, right? And this is an exception for the 𝚴𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋𝚋 this EL2 on the secure side does not exist, meaning your software or your CPU cannot operate as a secure EL2. That cannot happen. All right. So this does not happen, right? Secure EL2 does not happen. Okay. Now, another thing to note is the secure EL0, secure EL1, and the EL3 is all secure. And I'll talk about what secure means in a while. So the idea then is that the CPU, when it's operating in the secure mode or secure, it's with the secure features on or secure world, it's executing in the secure world, then it just means that it can access all of the resources on the system, right? It can reach out to any part of the memory and so on and so forth. But when we are talking about non-secure world, then that essentially means access to certain memory regions, certain addresses can be restricted, right? So that's the idea of security. And once I start to put examples, things will make a lot more sense. So if this is memory, right, then you can essentially, by some magic, partition the memory to be secure and non-secure, right? So when, let's say, your CPU is executing in EL1 secure, you can reach out, or the CPU can reach out to this entire memory. Any address is valid, right, within these two memory regions. But if you're in EL1, the CPU, then it can only access the non-secure part, cannot access the secure part.